Our first idea when we were assigned the collapsible bridge was to create a suspension bridge. We decided on a design that involved drilling holes in the end of 5 pieces of wood for a metal peg to slot into so we could connect the pieces of wood. We had 2 other wood chunks placed at the base of the bridge so we could balance it. We got some fishing line, and we tied it to 2 rods drilled into the bases so that we could get the bridge to hold more weight. The last addition to the bridge was to get 2 more foot-long pieces of wood and place them perpendicular to the 2 pieces of wood around the middle one. So like, if there's 5 pieces of wood, we placed them on the second and fourth piece of wood. And we ran the line over the top of those ones and through a hook that we drilled into the middle piece so that the bridge would be able to hold more weight. It made the fishing line tighter, which allowed the bridge to be more sturdy. Unfortunately, we did notice that the bridge was rotating around the metal pegs, so we realized that we would have to attempt to fix the issue.
For our second design, we asked ourselves how we could improve upon our initial design to make our bridge sturdier while still fitting within the parameters in the assignment. What we came up with was a similar yet refined suspension bridge design. We added an additional peg between each section for additional support. We also threaded the fishing line in an attempt to make it stronger, and we ran that line through certain pieces of the bridge. The result was a bridge that weighed about 4.5 pounds, but only held about 30, falling well short of the required 60 pounds. It was also not easy to assemble, which was disappointing because we liked the idea and look of this design. Unfortunately, we had to head back to the drawing board.
When we began the redesign process, we had to ask ourselves, what caused our second bridge design to fail so quickly? The answer, we decided, was primarily due to the shape of the bridge and the type of line used. The first and second designs were too flat, so the weight was distributed too heavily in one direction. This imbalance of force led to the early failure of the bridge. By giving the bridge an arched shape, we were able to better distribute the load, which allowed it to perform better under weight. This was a great improvement to the design of the bridge and allowed us to be more confident in its performance. The other improvement we made was the type of line used. Initially we used fishing line because of its strength and lightweight. After testing, however, we decided that it was too flexible and stretched too much. By the time the fishing line caught, the bridge had already gone from flat to U-shaped, which quickly failed to support the weight. To remedy this, we decided to use a less flexible rope. We decided to run the rope along the bottom of the bridge to counteract its response to weight. When weights were added, the bridge had a tendency to straighten out, pushing the 2 ends further apart. By using this less elastic rope, we were able to keep the ends a fixed distance apart, further reinforcing the strength of the bridge. The first and second bridges were also difficult to assemble. The pegs were hard to drill and put together. Additionally, they were not very strong, so we had to come up with a new method of assembly for the third bridge. We decided to scrap the 2 pegs and instead decided to go with hinges between the pieces of wood. The hinges would allow the wood to fold easily and be able to set up without worrying too much about putting it together. For the hinges, one end would have only 1 screw, while one end had 2, so that it could rotate and collapse more efficiently. Landon went home the day after we came up with the new design and cut, drilled, and assembled the bridge in time for us to test it on Monday.
As Davis mentioned, we designed a brand new bridge on Friday, and I was able to go home and build it that same weekend before the FEDD project was due. We were in a time crunch, and luckily I had the scraps laying around my house to pull this off. For next year, I would definitely recommend allowing plenty of time for research prior to building your first bridge. Thus, you have a better understanding of the strongest type of bridge to build given your criteria. Secondly, be sure to allow time for failure, because odds are your first design will fail. Had we not tested our second design prior to FEDD, we would have ended up with a bridge that collapsed under the weight of only 30 pounds. However, by testing prior to FEDD, we were quickly able to redesign and rebuild a new bridge, this time holding 85 pounds and collapsing at 95. Our bridge also only weighed 4 pounds this time instead of 4.8 and could be set up in just under 30 seconds. For improvement, we could have used thicker wood that would have allowed for longer screws to be drilled into it. Because as you'll see later in the video, our bridge failed only as a result of a screw slipping out of the wood. Also, we could have added hinges to the sides with a sturdier base. This would have provided for more stability in our bridge, allowing for less side-to-side sway. Now, if you'll watch closely as this video ends, you'll see a screw from our bridge fly out and nearly smack the judge on the left in the head. Enjoy the rest of this video, and remember next year to have fun.